Let's look at a few inverse trig identities. So this is specifically focuses on an inverse trig function and a trig function that aren't the same, okay? And I really try to key in on building a picture or a model from the inside piece and then working out. Okay, so cosine inverse takes in an x coordinate, 1/4, right? So takes in an x coordinate and returns to me this angle. So if I was on the unit circle, I'd think about this as being 1 and 1/4, right? And then it's going to return an angle, theta, in the first quadrant. What sine of that angle? Well, sine of that angle is going to be the y coordinate. How do you get that? You're going to get that by saying, well, if y squared plus x squared equals 1 squared, right? The Pythagorean theorem. So that, what does that mean? It means y equals the square root of 1 minus 1/4 squared. It's positive, of course, because we're above the x-axis. So that's the square root of 16/16 minus 1/16, which is 15/16. And so typically we would simplify that as root 15 over 4, okay? This is different. Notice the inside piece takes in an angle and spits out an x coordinate. What's that picture going to look like? Well, got my unit circle. Negative pi9 is down here. So this inside piece is going to spit out an x value right there, right? What does sine inverse do? Sine inverse pretends like that x value is up there, and it says, hey, what angle corresponds to that? So imagine you had that picture right here. You happen to know that this angle is negative pi9. So this angle would be positive pi9. So if you're mirroring that picture, this piece is pi9. And the question really is, how far is this piece left here? Well, the whole thing is pi halves. So you got pi halves minus pi9. The least common denominator is 18. So this is 9 pi 18ths minus 2 pi 18ths. And so your answer is going to come out as 7 pi 18ths. Okay? And you might just take some time to think about that process, build up your skills, moving these variables and thinking about putting the angles together. Okay, one more. Let's think about tan inverse of negative 4/3. Tan inverse is going to take in a slope and output an angle. Okay, with tangent, probably what I do is tan inverse thinks about quadrants 1 and 4. So I'm going to put a -1 in quadrant 4. What's a slope of negative 4/3 look like? It's rise over run. So go over 3, down 4, okay? And return me that angle. What's cosine of that angle do? It returns to me adjacent over hypotenuse. What's the hypotenuse? It's the square root of 9 plus 16, which is the square root of 25 or 5. So which is this going to come out with? 3/5. You could do this on the unit circle also. On the unit circle, you'd think about the slope being some fraction. It would end up being 3/5, -4/5, and 1. And you could get the same 3/5 as the cosine answer.